Hello and welcome to the first calculator programming video where I actually record the audio as a separate file. We are going to do a special video today, and by the way we're at Starbucks, so we're not doing the video in the normal location, we're doing it in a public kind of location. So Starbucks told me that they close this kind of lobby area in about 2 hours from now, so we're gonna have to make sure we don't do anything too crazy, like something that will cause us to run out of time or something. So anyway, here we are, and I want to give you guys some kind of tips and tricks and ideas on how to kind of take advantage of the TI basic language and kind of as a beginner just kind of do your best. So if you're kind of a noob at this, if you're kind of struggling and not knowing how to do this, we're going to go over some tricks here and there, and I want to kind of help you guys out so that you don't get too stuck. So the first thing that I want to go over with you guys is just kind of going to be general input and output. Okay, so I'm just going to do I/O. All right. So I'm going to show you guys kind of the buttons that I press as we go along, and that way you don't get too lost as to what I'm doing. Okay, so what I'm going to do is, starting at the home screen, okay, if you don't know how to do this already, we're going to press, well, I guess I should zoom out a little bit, possibly. Okay, let's just zoom out. Yeah, that should be okay. So, oh, I do want to zoom out a little more. I can just lift this up a little bit. So if you hit the program button right here, that opens your program menu. Okay. Okay, then we're going to press right, and we're going to go ahead and go new. Okay, and then what I'm going to do is I'm going to hit enter down at the bottom right. So right there, hit enter. All right. Okay, so our new program, and by the way, I want to kind of, in case somebody wants to do a follow along, I kind of want to make sure that this kind of suffices to do that. Okay, so right now I'm just going to press some buttons, and I'm going to enter in some letters. So it's already on alpha, so if you'll notice, if I press the green button right here, okay, I'm going to press the green button, and that's going to change. See, it's not alpha anymore. So if we enter anything in, like a 1, 2, 3, that's what enters in. So I'm going to press clear, and then I'm going to hit alpha again. See? Now it's locked onto alpha. Well, it's not locked. See, when I enter a T, it turns off alpha. So I'm going to show you how to do an alpha lock. So you go ahead and press second and then alpha. That's the alpha lock. Now it's locked. It's not just on one alpha. It's like kind of like pressing caps lock or something. Alright, so now I'm going to enter in, I'm just going to call it in-out, and then I'm going to press enter. So an in-out program, what is that going to be? Okay, let's start off with the basics. So I'm going to hit the program button. Okay, and we got this menu right here. If you press left and right, you can kind of select these different tabs. Okay, and now you can press up and down arrows to scroll kind of up and down on here. And you'll notice on the second tab right here, there's number 3 is display. So I can either scroll down to number 3 and hit enter, or I can just, from anywhere in here, I can just press the number 3. See, and it instantly gives me that option. Okay. So now I'm going to show you guys how display works. So display can take in a couple different parameters. So I'm going to press the program button again, and I'm going to show you when I scroll down to display, I'm going to hit the plus button right here. Okay, see that? It shows me what I can pass in as arguments to the display function. And see, I can scroll up and down and look at different things in the catalog. So I'm just going to press second and then the mode button, or quit. Okay, so I'm going to press clear from here already. So I'm going to press clear. See, it takes me back. That's how I just kind of escape out of menus by pressing the clear button. Okay, so display. Well, what do we want to display? Well, I'm going to go ahead and just hit the number 5. Okay. So right now, we're set up to display the number. I don't know why my... there we go. Come on, please stay in focus. Thank you. Alright, now I'm going to hit second quit, which means I left the program. Now hit the program button again. By the way, I just hit clear. That takes me back out of the menu. We're in the what's called the home screen. So if I say, 1 + 1 and then hit enter, we're just on the home screen. That's it. So I hit program. I go through here, and instead of editing it, I'm going to actually execute it. So look at the tabs at the top. I'm going to go to execute, and I'm going to press 6. So what this does right here, I'm pressing left and right. This is a command that kind of runs it. So if I add something to it and kind of mess it up, like 889 or whatever, it's going to be like, what are you talking about? This is an error screen. So I'm pressing up and down right here. Now if I press enter, it's going to say quit. If I press enter here, it's going to say it's going to go to where the error was. So quit's just going to go back to the home screen. Go to is going to specifically, it's still going to take me to the home screen in this case because that's where the error was. But go to will always take me to where the error was. So I'm going to hit enter, and it shows me, okay, this is where the error is. Okay, yeah. So if I delete the 889, now this is going to be a valid command, and what this command does is it runs the program. So I'm going to hit enter, and it ran the program, and see how there's a 5 up here? That's what happens when you say display. Numbers will appear on the right side of the screen. Now I'm going to hit program, and I'm going to go right for edit, and then I'm going to scroll down to number 6, in out. Okay, enter. Now instead of displaying 5, I'm going to hit alpha. Okay, see that A? I hit the green button. Or on your calculator, let's see, the other T84. No, it's still a green button. Usually it's a green button. Now I'm going to hit the plus, but I'm not pressing plus. I'm really pressing quotes. Okay, you guys see where that is? It's right here. So when you hit alpha and then you hit this, instead of it giving you a plus, it's going to give you quotes. All right. So I'm going to display a string now. So now I'm going to actually do an alpha lock. So second alpha. Now it's locked on. And let's say hello. Hello, and then a space. So the 0 on my calculator has a space in green. That's kind of what this underscore looking thing right here is. That's a space. Okay. Do hello world. And then I'm going to press alpha, and that's going to turn off the alpha lock. Okay. Now how do I get an exclamation point? Well, I'm going to hit math, and then I'm going to press left. Okay. See how at the top, when I press left, it popped over to the right side. See, if I keep hitting left, it keeps restarting. If I hit right, it keeps restarting. Okay, so I'm gonna go in this section right here, prob. I'm sure prob probably stands for probability. So it's just short for probability, and you got random functions right here. Now the exclamation point, that's a factorial function. That's used in probability theory a lot because it kind of gives you a counting of something. So it gives you kind of a number of choices, or it's used a lot in these other functions right here, NPR, NCR. Factorial is really important. If you ever take like a probability class, you'll realize like, wow, that's a really useful function right there for that. So, but what it really does is it just takes a number like 10 and it multiplies 10 by 9, by 8, by 7, by 6, and so on. But we're going to use it, since this is the only place in the calculator where the exclamation appears, we're actually just going to use it as a character in the string. So go ahead and hit enter right there. And now we have a hello world with an exclamation point. Now usually, so I'm going to hit alpha and then I'm going to hit quotes. Usually you would need kind of that last one right there. So if I hit delete, notice how nothing happens. It doesn't kind of backspace. So what delete actually does is it deletes the character that we're currently selected on. If I were to hit clear, this whole line would be erased. I'm going to press left and then I'm going to hit delete. Now, why, Tim? Why did you delete that quote? Well, we're going to run the program and see what happens. So I'm going to hit second mode or quit. Then I'm going to hit program and I'm going to go down to in out. Actually, forget that. I'm just going to press 6. See? Now I'm going to press enter. And it says hello world. It worked. It didn't crash or anything. Okay, so I'm going to hit program and go to edit and then hit 6. And see, it still worked with or without that quote. And that's because it automatically ends quotes. Whenever a line ends, it's gonna end whatever's not there. So if there's any open parentheses or any quotes or anything like that, it'll just finish them off basically. So you don't have to worry about them. Now I'm gonna hit alpha lock and I'm just gonna say kind of like OPQRSTUVW. Now notice I'm gonna hit alpha again. Notice how we went off the screen and we went back, but there's not a 2 dots here. Now if I hit alpha and then I go ahead and I hit the period, I'm not entering in a period, I'm actually entering a colon there. I'll show you what button it is. It's right here. There's a colon. And that actually started a new line without actually giving me a carriage return. So I can actually hit program and I can go in here, go into IO, I can say display. And then we'll just do 5 again. Now second quit, program, 6, enter. It actually showed display. See that right there? You know why that showed up? It's because it's still within the quotes. Anything you put in the quotes, even if it's a command, is going to show up. So I'm going to go edit this program again. Okay, and I'm gonna put in some quotes right here. All right. Oh, not right there actually. Okay, so you guys are probably wondering, so I'm just going to undo that. I'm going to show you how I just did that. So how did I put that in there? Okay. First of all, I'm going to move to where I want the quotes to push everything else to the right. So I'm going to press left. I want the quote to go right there. Okay, so how do I do that? I press, see that? That's insert mode. So if I press second and then I press delete, that's the same as pressing insert. See, now it's instead of the character showing up a full character, it's just a line underneath. Okay, it's in an insert mode. So now if I hit alpha, you'll see it's a inverted alpha right there, and I think you can also do an alpha lock even on insert mode. Now I'm going to hit the plus key, and that will give me a quote. Okay, so how do I get out of insert mode? I can hit second insert again, or second delete. So to get in and out of insert, you just go back and you just hit insert again by pressing second delete. And that will switch you in and out of insert mode. Okay, now I'm going to press second quit. And this time, I'm not going to go into my menu. I'm actually just going to press enter. Okay, so what does enter do? Enter on a blank screen is going to give you your history. Okay, so if I press second and then enter right here, that's entry. I can hit it again. Second entry, second entry, second entry, second entry. Ooh, what's that? See, it's going through my history of what I entered. Second entry. See? Oh, 1 + 1. So I'm going to press clear because we're not going to enter that. So notice how up here when we ran the program, it displayed both of those things, even though we'll go back into it by pressing 6, even though it's all on one line. So if you want your program to be compact, you can just put extra quotes like that, okay? Alright, so let's kind of move on to a couple harder things and just get into some programming tactics, okay? So number 1, we'll just say that was some basics. Okay, so number 2, let's go and talk about some other tricks. So, oh no, tutorial was the program where we talk about this. So I'm going to go back to tutorial, and I'm going to say, hold on a second. I gotta make sure that I'm still recording. Good. Good. Okay. My computer locked up. So I/O is still what? Let's go ahead and since I taught you guys something else, I just taught you guys some basics. So let's just say the first part was basics. Okay. And so now we're gonna do the I/O. Alright. Okay, so I showed you guys display, okay? Now let's talk about prompt input and output, and then I'll show you guys getkey, okay? So this is a whole bunch of, this is more I/O. Yeah. So let's go ahead. We'll display 5. We'll display. We'll just display high. Okay. And then we're gonna do a prompt A and a prompt B. Okay. And then we're gonna display A plus B. So what this does is prompt is just, it's a really quick way of just asking the user for that value, and then we're going to show what it is when we add them. So I'm going to quit out of this, and I'm going to run the program again just by pressing enter, and then it says hi, and it says 5, then it says hi. What's A? Well, A is, let's say 8. What's B? Let's say B is 2. It's going to add them together, and there we go. It displays a 10. Okay, so I'm going to go back to I/O, and we're going to go ahead and show you guys the next I/O thing, which is output. Okay, so I want to output at the bottom of the screen. I know that the screen is 10 lines tall, and you always put the Y first and then the X. So you always put the vertical position starting at 1 at the top and 10 at the bottom. So we're going to put it at the bottom. So we're going to put a 10. And then for the X position on this calculator, by the way, if you have a TA84, that's not a CE. It's going to just be 8 tall. If you have a TA83 or a TA82, you'll put an 8 here. Okay, and then mine is 26 wide. On the other ones, it's just 16. So you guys will have a smaller screen. So I'm going to put 20 on here. If you guys, that's 6 characters to the left. So you guys who just have T82s, T83s, or T84s, not the CE version, just put a 10 for the X. So put 8 and then 10. And then we'll just put corner. Okay, so I'm going to quit out of that, run it again. 5, 5, 10. Uh-oh, core done. Okay, so our program is saying done at the end. So let's see, edit. We don't want it to say done at the end. So what I can do is I can do a let's do a pause. I'll show you guys a pause. So second quit. Let's see what happens when I do a pause. Okay, it says corner. Now notice how it's completely frozen. You'll know, and the other calculator, you know it's on a pause because the upper right of the screen will have like a shifting thing. On mine, I think it's this loading thing. I'm not sure. Let's see. Yeah, see that? Well, okay, well, anytime it's computing, I don't know. On the CE, it doesn't really have the same indicator, but a pause, you'll definitely be able to tell if you have an 82, 83. If you have an older calculator, you'll see kind of some dots. In fact, I can show it to you. So let let me show you on a TI-80, my old TI-84. Let's do this. Let's do a new, and we'll just call it A. So we'll go to, sorry for the lighting. My lighting is definitely set up for that other calculator. Okay, see that? That's what you'll see with the pause. Okay. Okay, and then when it's running, it does something different on the older calculator. So I'm going to edit A, and I'm going to put it in an infinite loop. So I'm going to say while 1, and I'll show you guys how to do this later on the other calculator, but let me just show you. This is what you'll see on the T82, T83, T84. Whenever it's computing something, running something, you'll see kind of this like shifting upwards slowly. Okay, so I press the on button to break out of that, and that kind of creates its own error called break. So it's like a special type of error that basically says that you can control, like you can cause it to happen whenever you want. There we go. So, I don't like how that light is on there. I don't know how to block that. Oh. I'm trying to block this light so that it doesn't show up. And I'm having trouble blocking it. Come on. I wish there was some way I could block it. I don't know how. Just maybe move this to the right or something. I'm not sure. Okay. Nope. Alright. I don't know. Maybe I don't usually adjust my camera while I'm recording, but I guess I'm doing it this time. Anyway, let's just maybe this will work. Oh. Okay. All right. So. There we go. I'm going to hit the on button, okay, and then I'm going to press enter, and it's just going to quit, okay. Press clear, and then hit program, and we're going to go back to in out. Okay, so we did a pause. Let's do a get key loop, okay. So what we're going to do, I'm just going to clear all this stuff. So you guys should know how to use those. And I'm going to do an infinite loop with a get key. Okay, but I'm just going to, what I'm going to do is I'm going to display get key. Okay? So I'm going to show you guys what this does. If I hit this program and I run it, it's going to show me zeros. Okay, that's showing me what buttons I'm pressing. Okay, now I'm going to press the up arrow. Okay, nope, that was graph button, sorry. Up arrow, 25. Left, 24. Right, 26. Down to 34. Notice how it's just printing tons of zeros, and that's kind of annoying. If I hit the second key, it's going to show me a 21. Okay, so how do we change this so it doesn't do zeros? Well, the easiest way is to just go in here, and we can actually store get key. Okay, so the store button, by the way, is on the bottom left right here. That's how you save a variable. Okay, and then you can just save it into any kind of variable you want. So I'm going to press alpha A. So I'm going to just store get key into A, and then I'm going to just display, I'm going to say if A, okay, oh, if A, then I'm going to say display A. And you're like, what are you talking about? If A display, like what do you mean if A? If A is what? Well, take a look. Okay, nothing's happening now. Press up, down, left, right, second. Okay, so now I can see, I can press any button I want and see. Here's the zeros number. So if I hit the 0 button, it's the 102 button. Okay, anytime I hit it, it gives me a 102. And anytime I hit the enter button, it gives me 105. Every button works except the on button. On button will quit. Okay. So why did this if A work? Okay. So the way if works is it checks to see if something's true or false. And on the calculator, the way the TI basic works is they use numbers for everything, including trues and false. So that means they actually check to see if something is true or false just by checking to see if it's 0 or not. So if it's a 0, then it's false. If it's anything else but 0, then they call it true. It evaluates as true. So if you want to see if something's not 0, if you want to see if something has any value other than 0, then you can just check, is that value, you just ask if that value is true, basically. You just say, is that value true? So I could say, here I'm going to hit enter and then math or test. See, you got the equals right here. So I could say if A equals 1, or if A does not equal 0, or if A equals true. Like, well, they don't really have a true, but if is really looking for a number here. And the true and false is represented by a 1 and 0, not just a bit or a byte, but just whatever TI's number system is, it'll use that. Okay? So that's how we do that. Okay, so how do we do like a game loop thing? Because like here, like let's say I want to do something else here. Let's say I want to like display 5 every time. Okay, so now if I run the in-out program, okay, it's going to be displaying 5, and then if I press up, down, left, right, you know, it's kind of displaying all these 5s, and I don't want to do that. What I want to do is I want something to happen in the game, but I want the game to wait for me, kind of like the pause does. It kind of just waits for me. Okay, so the way you do that is you want to get what the user gives and then wait for them. Okay, so there's something that's just like the while loop, except it's a little different. It's called the repeat loop. When you run the repeat loop, it keeps doing something. Okay, it keeps repeating something until the statement is true. So while loop, it keeps repeating something while the statement's true. So it's gonna, before it enters it, it's gonna check if it's true. If it's true, it does the while loop and then it returns. The repeat loop is different. The repeat will do it while it's not true. Okay. So I'm going to say repeat A, and then I'm going to put getkey stores A. So the reason why I do this, I could actually store, like, I could start with 0 stores A, and then I could do repeat A, getkey stores A, and then in here, or sorry, after this, I'll display A. Okay, so the way this works is it's not the best program yet, but I'm just going to show you it does work. So if I press up, boom, 25. Now if I press left twice really fast, it only shows me 24 once, but it should have showed me it twice. And I'll show you guys why. So if I hit the second key twice really fast, boom, boom, it only showed me once. So I'm gonna go into the program and I'm gonna show you something. What's happening is no matter, so it's gonna get the key, but then there's a problem. Once it restarts up here, it's gonna set it to 0 even if getkey had a value, and it'll lose that value because getkey only lasts a certain amount of time. So basically, if I press like the second key, it'll store 21 to here, display 21, and it will come back up here. And then it'll store 0 into A, and then will repeat while A is not true. It'll store getkey, which was 21. I think it's like a timed thing. I'm not sure. But I think actually this technically should, if there is a queue, then this should do the same thing. But I think I always do it the other way because it's a timed thing, I'm not sure. But usually what I do is instead of putting a 0 here, I put a getkey here. So I actually have 2 of them. So that it, you know, it tries to catch one at least. So if there's a 5, second. You know, it's still only going once anyway. So you can put a 0 stores A, you can put a getkey stores A. I think they'll both kind of do a similar thing. Okay, so that's how you wait on the user. So I think we've gone over almost all of the inputs and outputs. I'm going to show you guys ClrHome really quick. So let's go ahead and do this. Okay, so ClrHome is really nice because it clears the home. See that? It ran the program blank screen, so it's really nice. The last thing I'm going to show you is the input command. So this is really important. It's kind of like the prompt, but it's better. So what you do is you start with input, and then you put a question. You can put like age. Okay. And then I think you put a comma. Do you put a comma? Let me try that. Age 5. Okay, now 5 stored in A. So yeah, you can basically put a string, and then it asks you that. So I'll show you guys like a trick. This is what I like to do with inputs. I like to put nothing for the input string, but then up here I'll put display, you know, I'll put the question. So this is how I like to do my inputs a lot of the time. If you watch my videos, you'll notice that if I ask questions, I usually set them up like this. And the reason why is because it gives you kind of like your own line. So let's go ahead and run the program. I'll show you what I mean. See? So it asks on one line, and then it lets you enter on the next line. Like, okay, I'm 28. Okay, and then that's stored into A. So yeah, that's pretty much how you do input and output. So let's go ahead and go back to the tutorial and say, you know what, we did input output. Let's move on to something new. So notice how everything, I probably can't avoid this, but I think everything's kind of, at least for now, it's gonna build on the previous one. So they're not really independent yet. So let's do some screen. We could do some screen wrapping stuff, but I kind of do that every episode. I could do kind of like a mover example. But I kind of explain it every time I do it in all my videos. Basically what I do is I use the arrow keys with the input output that I just showed you, and I let you move around with a little guy on the screen. But the thing is, I kind of explain that as I do that most of the time, so I probably don't need to do that again. Yeah. So I had some other ideas of how I was going to, here's my collats. See, I use the getkey, repeat G, getkey here. to kind of get your input on whether you're pressing left or right. Okay, and then notice that in this program I'm using outputs, and I'm putting coordinates, and I'm kind of like displaying it different parts of the screen, so that's easy to kind of see it controls. And I also have an infinite loop, which is fine. You can use those. You can also use the stop command, which ends the program. Okay. Let's go ahead and look at A. Okay, this is my just kind of title screen. Here's just some mathematics stuff. Okay, here's just something that outputs a whole bunch of random numbers on the screen. That one's a blank program. Here's some more mathematical stuff. Okay, this is the quadratic formula. Forgot about that. Rule. Okay, see we got prompts, displays. Whenever you make short programs that just do some math, you want to use displays and prompts. They're the quickest, easiest way to do it. We got store picks. Yep. So I'm just kind of looking through my different programs here and seeing just how much I use these. It's a lot. Okay. In my Tetris, I use something different. I use the drawstring. So all these things with pick and draw and all this stuff, that's a different screen. That's not the character screen. It's the draw screen. So that's the one where you plot. Whenever you hit the Y equals button up here at the top and you plot something, that's that same kind of screen there. And we're not going to really cover that stuff, I don't think. Although we could, if you guys wanted to. I really want some feedback on what causes you guys to kind of stumble around. And yeah. So basics, I/O, and I guess I could show you guys how to do maybe like a subroutine. Okay. Subhack. So this is kind of unconventional here, but this is a way to do a subroutine. And we'll just go ahead and try to do that. So let's make a new program, and we're going to just call it hack, because I think this is kind of like a little bit of a hack here. But it gives you kind of some functionality, and this is what someone taught me in high school. So I want you guys to think about what's going to happen when I do this, okay? So I'm going to say for -1, okay, is, oh, sorry, not for -1. For A is -1 to 0. Okay. And then I'm going to say if A, and I'm going to say end here, and then I'm going to use a goto. Okay, so I don't recommend usually using gotos. But this is how this works, okay? I'm trying to remember how to do this. Okay, so the way a goto works is it kind of jumps around. I don't recommend really using them because you don't really need to. But I'm going to say go to F. We'll call it F, and then label F. So this is kind of a spot in the code, and it's going to say, it's going to display, I don't know, hi. And then it's going to, let's say, make it display the whatever is stored in B. And then we'll just say end right there. Okay? And then up here, we'll just say 0 stores B. Okay? So you'll guys notice that I'm gonna put a stop right here. Okay, and then we'll put a clear screen at the start. ClrHome. Okay, so let's walk through this. Okay, so the whole screen is gonna clear here. B is gonna be 0. Okay, no big deal. Okay, now for A is -1 to 0. What does that mean? Okay, so what that does is it's a for loop. It's gonna use the variable A in this, and it's gonna make it -1. And then what it's gonna do is the default number, the fourth parameter, the default is 1. So we don't have to have that 1 there, but that's the default. So I'll just put a 1 there to explain what it's doing. This is called the counter on the right side. That's how much we're adding to A each time. Okay? So it's going to start at -1, and then it's going to run through everything until it hits an end. But you'll notice that we have an if A here. Now, if you just have an if and you don't have a then, it doesn't expect to see an end. And the way TI Basic works is it actually doesn't enforce which end goes with which if and which for loop or anything. Any end will do. So if it sees this A and it sees that it's not 0, okay, since A is -1, it's actually going to do this goto. So while it's in the for loop, it's actually going to jump past this end. It's going to go to label F. Then it's going to display high, display B, and then it's going to hit end. Now it thinks that this end belongs to this for loop up here. Which it can, I guess. And so that's why it's kind of a hack, because it's kind of silly, because now this for loop has 2 different ends. It comes back up here, increments A, and now A is 0. Okay? So now it sees it, and it says like, okay, you know. Okay, so what we're going to do is we're going to display high again. Okay. And then I'm going to store 1 into B. Okay. Okay, and then here I'm just going to go to, I don't even need to go to F. You know what I'll do is I'll just erase that. Okay, so it's going to do this code at the bottom twice, and then it will crash because it hits an end. Okay, yeah. Okay, so see how it says 0, high, 0, high again, and then high, and then 1. So it did the subroutine. So the subroutine does high, and then it displays B. High, it displays B. So if you have a subroutine that's really complicated, a lot of code, you don't have to write that code twice. You can make it be called from different parts of the program. So to keep this from crashing, what we can do is we can put a stop here and kind of separate the subroutine from the rest of the program so you don't reach it. Okay. And then what you can do is you can call it again. So you can say for A is -1 to 0, okay? And then you just say if A go to F. Okay. Bam, and it's done. So that's how we do a hack subroutine. So if you guys want to use that, alright, this is how you do it. You can make subroutines. You just gotta do it that way, okay? Now I want to show you guys the non-hack subroutines, okay? So I'm gonna show you guys kind of how to do recursion and how to make kind of like do it on this calculator, because it's kind of tricky. it's kind of hard to tell. You kind of have to use an extra variable to kind of tell how deep you are, I guess, because you can't really pass parameters, but what you can do is you can set variables. So let's go ahead and do like a, I don't know, we can do like either the Fibonacci sequence or we can do like a factorial function or something like that. Okay. And I don't really like doing the Fibonacci sequence this way because it's really slow, but yeah, you can call other programs with your program. So we'll call it fib slow, because obviously this is not a good way to actually calculate the Fibonacci sequence, but it's an easy way to show recursion though. So we'll call it fib slow, and what we'll do is we'll just set we'll set, let's see here, we'll ask prompt, no, we'll say yeah, we'll prompt A, and we'll just, A is going to tell us how far to go. So how far should we calculate? So now we want to add, we want to kind of add A minus 1 and A plus 1, the Fibonacci's of those. So, no, let's say n. So to calculate Fibonacci of n, what you do is you add it to the Fibonacci of n minus 1 and the Fibonacci of n minus 2, as long as neither of them are 0 or 1. Okay? So yeah. But in this case we can't really call functions and get return values and stuff like that. We have to use state, and then we can't even, it's kind of silly. So how do we do this? Well, we're going to start off by quitting out of here, and we're going to create a new program called fib call. Okay, so this one gets called. By the way, if I press second and then I press recall, which is the store button right down here, okay, then I can, it shows me recall, okay, and then I can hit program, I can recall all sorts of different memory. If I hit program and I go down here to, I don't know, tutorial, and I hit enter, boom, it just copied that program into this program. But we don't want to do that right now. That's just a side note thing. Okay, so fib call, what's it do? Well, let's kind of choose a variable, let's say p. Okay, so p is going to be what we set before we call fib call. So we're going to ask it, we're going to ask at the start of the program, we're just going to find out what p is. So we're going to say if p is less than or equal to 0, then we want to return, oh, by the way, return, it's not going to return a value, but what it's going to do is it basically stops the program, but it goes back to the program that called it. So if p is less than or 0, we're going to want to return, and by the way, if you use a then and an if statement, if you just use an if, it'll just do the next line if it's true, and it will skip it if it's false. If you use a then, it will do all the following lines until it reaches an end. Okay? Unless you use gotos, then it gets all messed up. Okay, so if p is less than 0, then we're going to return, we're going to set the r is going to be our return value. Okay, so 0 stores return. Okay, and then we're going to check if p, okay, is equal to 1, then we're still going to want to return. Okay. P is equal to 1, then 1 is going to be the R value. Okay. Okay, if it's not, then what we're going to do is we're actually going to... Now this is the part that's really, really confusing, because if we're going to have a whole bunch of fib calls all at once, so this is actually really confusing, but I just realized that just using R is not going to work, because this fib call is actually going to have to call 2 other fib calls, and if it changes, if those change what R is, then I can't know what R was here. Okay? So it's really confusing, but this is exactly what I wanted to happen, actually, come to think of it. Okay? Because I wanted to teach you guys what real recursion was here. Okay, and that's exactly what we're going to do. So, real recursion. This is how we're going to do this. This is going to be crazy. Okay? So I'm going to prompt n. Okay? Now I'm going to delete. Okay, I'm going to press second, and then I'm going to press catalog, or 0. Okay? Press alpha, and then D. You guys don't really have to do this, okay? But I'm gonna delete variable list1. But the only reason is just because I want a clean startup. You don't really have to delete it for this to work. But I just want I want to be able to debug and look at it. So sometimes it's nice to delete it before you use it, because then when you can look at the variable while you're debugging. When your program kind of crashes or something, you can open up list1 and see what's inside. And it doesn't have extra junk on it. So I'm going to delete list1, and then I'm going to start with an index, and I'm going to start it with, I'm actually going to start it with, I'm going to start it with 0. Okay. Okay, and then n is already going to be set. Okay. This is the reason why recursion is confusing, is because while you write a recursive call, you're assuming that the function is already written, kind of. It's kind of silly. Okay, so we're going to pretend that fib call works exactly how we expect it to work. Okay, and the way it's going to work is it's going to increment I. Actually, you know what? Hold on. I lied. Okay, hold on a second. I'm trying to think here. We're not doing this for the purpose of calculating fib quickly, but we're doing it for the purpose, we're using the list for the purpose of doing recursion to find out which call we're in. So we're going to use, basically we're using a list as a stack. So I'm going to store, I is going to be the index of where we are in the list. I don't know if I need to store the first value, but I might want to store n into the first value before I do the fib call, to kind of show where I'm at. I think. That's how I want to do it. Okay, so the way it works is I'm gonna call fib call and then I think I'm gonna add everything as I go down the, come back up the tree. So I'm gonna add to R. So I think I'm gonna do a display R. Okay, I think. Yeah. Alright, let's go to fib call. Okay, so we have P here. So what we can do is we can say list1 of I store is P. So what that does is that gives us I as a counter, and P can change, but we can always get it fixed. Okay. List1 I stores P. Let's see here. Return if P equals 1, and 1 stores R. Okay, so instead of just storing 1 into R, what we do is we also return. Okay, so if we could do it with the global, or we could add it to the previous one. I think it's silly to pass down to just use an R for everything, because then we could just, you know, if P equals 0, then just return, you know, and then here we could just do R plus 1, you know, stores R, or whatever, and then if P is more than that, then basically you're doing a fib call. You do basically I plus 1 stores I, and then you're storing into L1 P minus 1 okay, and then you can call fib call right here. Right, so that's gonna add 1 less than it, and then you could subtract 1 from I. And usually I put the incrementer before and after the entire thing. I'm not sure. Yeah, so okay, so to get P again, L1I stores P. So obviously this call could rewrite P, so I'm gonna okay, then I'm gonna do P minus 2. Okay, so what's going on is I'm doing recursion by calling itself, and it's calling itself twice, so it's a complex recursion tree. It's not just me calling myself once. It makes kind of like this, not really a binary tree, but a tree with a lot of, well, I think it's considered a binary tree. Because each node has at most 2 children. So, yeah. So, and this is wrong. I need to do I minus 1 right here. Okay, so this gives me the original I. So I'm adding to the index, and then no matter what this call does, okay, no matter what this call does to I, it'll return I to its original state before it comes back. So I know that this I will be the, one added to it, the original I. So I know that I minus 1 is going to be the same I for the fib call, which means that whatever's stored there, that's going to be my original P. So all I'm doing here is I'm just resetting P to whatever it's supposed to be. Okay, then I have P minus 2 instead of P minus 1. And I'm storing that into the new I, and then I'm calling it again, and then I'm restoring I back so that when I return, by the way, I'm going to do return just to make sure. I think it will return without me putting it, but just to make it explicit. I think when it hits the end of the program, it should return. So let's see if this works. N equals, 5, 243. Okay, so it's 5 plus, what's n of 0? Well, it's 0. What's n of 1? Well, it's 1. What's n of 2? What's 1 plus 1? Okay. What's n of 3? It's 2. What's n of 4? 3. 5. So 243 is a big number. So let's set 0 into R at the beginning of this and try doing that again. Good. Let's try 6. Good. That's correct. Let's try 7. And notice how it takes really, really long. I purposely did that. You don't have to take that long. You can actually do this extremely quickly. But what's cool is what's going on with the code, and by the way, this is useful in a lot of situations where you do need to do it this way. This is actually going all the way through that entire tree. Wait, what? It's 34? Let me see this. What's 7? So apparently 21 plus 13 is 30. Yeah, it is. So there you go. That's how you do recursion. Do you guys understand what's going on here? I have 2 calls, fib slow, or 2 programs, fib slow and fib call. Fib slow calls fib call once, fib call calls fib call twice. Okay, so we run fib slow. 0 is going to be an R. Okay, it's going to set I. Okay, it's going to start off as 1, and then it's going to go into fib call. And R is going to be like our accumulator in this case. It's going to basically count for us. Okay, when we get into fib call, we're assuming that I is just, whatever it happens to be at this point. Okay, so the first time it's called is going to be 1. Okay, but whatever it is, we want to take whatever's in list 1 at that point, and we're going to store it into P, and that's, okay, it's going to be our value that we're working with. Okay, so if it's 0, we don't mess with it with R. If it's 1, we just add 1 and then we return. But if it's bigger than that, we need to call ourselves twice, not just once, twice. So if we're 2, we need to call 1 and 0. If we're 3, we need to call index 2 and 1, and that's how we do this. Okay, I is going to give us, I just means, since we're adding to it, it just means that we're going 1 deeper. So we're using the list more. So let's take a look at the list. See? This is we're going deeper. Why are the numbers getting bigger towards the right side? Smaller towards the right side. I don't get that. Something silly about that. Maybe that is how it works. Not sure. P minus 1. P equals 1. Yeah, so yeah. So yeah, R is going to accumulate for us. P is telling us how deep we are. I think, yeah. And there you go, that's recursion. I kind of wanted to touch on like 5 topics though. So let's go one more, if we can think of one. What is another topic that we could do? Display strings, or let's look through the little I don't really want to show you guys how to convert a number to a string or something like that. It seems very hacky, but it is possible. How about matrices? How to use a matrix? Yeah, we can. I guess we could do that. Yeah. Let's do some matrix stuff. So let's just go ahead and make a new. Whoop. Let's make a new program called matrix. Okay. Alright, so if I press second, okay, and then x to the minus 1, we get this matrix menu, right? And there's different things here. So we got names, math, and edit, okay? So this will give us a matrix. It's kind of like getting a program, okay? So you get one, and, well, it just kind of is a matrix. So if I can do something with it. So for example, I'm going to insert a display here. Okay, so I'm just going to display, okay, when I run the program, it's just going to display matrix A. Okay, so that's what it looks like when you display it. Alright, see that? It's just a big glob of, and then there's a done, so I can't even scroll around. Okay, if I go into the matrix menu though, and I go into edit, here I can kind of like scroll around and like set values and be like, no, I don't want that to be a 23, I want it to be a 5. Enter. No, see, now it's a 5. So how do we use these things? What do they do? What's so great about them? Well, a matrix is a 2x2. I mean a 2x2. It's just a 2-dimensional set of numbers. So if I want to display, like, let's say matrix A 5, 5, that's going to give me a specific value in the matrix. Okay. These are really useful things. So I'm just going to show you guys how to kind of make use of them. So you're going to start off. I usually like to just delete them. So I'm going to press second and then press catalog, which is the 0 button. Alpha D. Oh, it's not working. Alpha. See the alpha in the upper right hand corner? She's made that alpha. D. There we go. Scroll down to delete bar. I'm going to delete matrix A. I like to use A a lot because then I'm not using too much memory. I'm just reusing A. Okay, so now A is just going to be an empty matrix. So let's put something in it. Let's change its size. So what I'm going to do is I'm going to say dimensions of A. Okay. But before I do that, actually I'm gonna display that if I can. We'll see if that works. I'm going to store a let's see if this works. Let's see if that works. I'm not sure if I did that right. Okay, so 2, 1. That's the size of the matrix. Alright. So dimensions of the matrix is going to be its size. So it's 2 in width and then 1 in height. Okay, so if I add 1 here, it's 3, 1. Okay. Okay. Now each of these could be like a row. So if I could put 5, 4, 6, 7, 3, 1. Maybe commas will work, I'm not sure. There we go, 3, 2. Okay, so this is the syntax. Is what you do is you basically take these bracketed lists that are the same length, okay, and then you put them in a bigger bracketed list. And that what that gets you when you store that in a matrix A is that gives you a hard-coded matrix that looks just like this. See that? You got rows and columns. So we got 3, 2 is the number 1. Okay. So 3, 2 is the number 1. So the first one tells you what brackets you're in. So this is the first one, this is the second bracket, this is the third bracket, and then 2 gives you that x value. So it's kind of like a y value then an x value. So what I like to do is I like to take advantage of the fact that a matrix can be the same kind of size as the screen. So I like to take, and for the other calculator it's going to be 8 and then 16. So here it's going to be 10 and 26. And remember I told you it finishes the brackets, so I don't have to put a bracket here. I can just store this and it will automatically end the bracket. And I'm going to store that into matrix A's dimension. So I'm setting the size of it. Oops, so I'm going to go into matrix, put the A there. Okay, so when I run this, okay, it's 1026 in size. So if I go to matrix and I edit it, it automatically fills it with a whole bunch of zeros. Okay, but what if I want the whole thing to be zeros, including these numbers that were already up on the upper left? Okay, so that's where this comes in. Okay, you don't have to delete the whole matrix. You can actually just fill it with zeros. So I'm going to go to matrix again, and I'm going to show you this command. You put the value and then the matrix name. Okay, so I'm going to fill it with zeros. 0, matrix A. Boom. Oh, wrong menu. See, now it's all zeros. Okay. So what if we want to edit a specific value of the matrix? Well, we can. We can store like 7 into matrix A. let's store it into y is 1, but x is 3. So that should be on the top row, third column. Okay, there we go. Let's go to matrix and we'll edit and see, it's there. Now you guys might wonder why, okay, why did it show the 7? I didn't say display 7. Why did it show it? Well, that's one of the things, is if the last piece of code in your program is to store a number to a variable, TI Basic just prints it out to the screen. That's just how it's set up. Okay. Alright, so what we can do is we actually have a different number for each part of the screen. So we can actually go through and we can just loop. We can say with 4 loops, we can do that. Okay, so for x is 1 to 26. For y is 1 to 10. We can output at the coordinates y, x, whatever's in the matrix A at y, x. In which case will be a whole bunch of zeros and a 7. See? Oh, the done ruined it. It shifted everything up, so you couldn't see the 7 anymore. Maybe pause will keep that from happening. We'll see. There you go. See that 7? Alright. So what I like to do is I like to have things in the matrix, and then I'll say if matrix A, you know, y comma x is not 0, then we'll display it. So now it'll be all blank except the 7. Okay, but the screen wasn't cleared, so you can't really notice what happened there. So go ahead and ClrHome 8, then run it, and then you'll see the 7 up there. Okay, so now we can kind of store whatever we want. We can put like a 5 into the matrix at, I don't know, like 8, 8 or something. Boom, shows up right there. So that's how you use a matrix. You can kind of see when we do Zelda, you can kind of see if something's on the screen somewhere, because I'm not just storing it on the screen. I'm not just outputting it on the screen. I'm actually storing everything into a matrix, and then every time I move, I'm just seeing if it's in that matrix. I usually use matrix A for that when I do that. Okay. So, not sure if I did a good job doing this tutorial, but we kind of went over some basics, some I/O, a subroutine hack, recursion, matrix. Recursion was really confusing because we used lists. Okay, so maybe I should just go over lists with you guys. This is actually going to be easier. This is going to be easier than matrix and recursion, and probably even subroutine hack. I don't know. Lists are pretty simple. So lists, I'm just going to show you list 1. Boom, it's right there. Now if I say list 1 of 1, it gives me a 7. If I should say list 1 of, I don't know, 3, it'll give me a 3, because I'm indexing the list. Okay. Now if I say 5 store is list 1 5, and then I show list 1 again, the whole list, I just set that number to 5. Okay, 6, 7, and 8. So I can actually store something into list 1 8. Okay, so let's store 105 into list 1 8. Okay, oops. So I just pressed second enter twice to get this last entry. Okay, now I hit enter, and bam, it just added one to the list. Now can I add one to list 110, or will something bad happen? Nope, you can't. Okay, so you can always add one to the end of the list, but you can never add one past the end of the list. It's just how lists work in TI Basic. Okay, so you always have to grow lists from the bottom up. You can't just add to a list. That's just how they work here. But you can always go ahead and just pick where you want from the list and get that number. So I use this list. I used it to help do the recursion, because the recursion doesn't let me pass parameters, doesn't let me return values. So I have to use the list to kind of keep track of the memory, if you will, to keep track of the stack, to see how deep I am in the recursion, how many of those. Otherwise, there's no way to track it. So there's different things you can use lists for. You can use them to store numbers. You can use them to do all sorts of stuff. In fact, with the Fibonacci sequence, we can actually make a fib fast. So let's do fib fast. Okay. And the way this works is we're going to start with, we're actually going to just store everything in a list. Okay. So we're going to prompt M, and we're not even going to use recursion on this one. We're actually just going to use the list. And I'm purposely going to make this one fast, and just like I purposely made the other one slow. So whatever n is, we're gonna count up to that number of things. So we're gonna store 0 into list 1, 1. We're gonna store 1 into list 1, 2, and then we're gonna say, and then we're gonna store 1. No, we're gonna store 2 into our counter. Okay, and we're gonna say while C is less than, and then we'll do n plus 1, I think. Okay, and then we're gonna add 1 to C. C plus 1 stores C. Okay. And what that's going to do is we're going to actually 3 is going to store into C. Yep, because we already stored something into list 1 and 2. So we're going to take list 1 C minus 1. We're going to add it to list 1 C minus 2. We're going to store that into list 1 C. Okay, and then at the end, we're just going to display list 1 C minus 1. So we're going to see the last one that was stored into it. So let's do fib fast. Okay, so 8 numbers. Okay, we got 13. I'm not sure if this is right. Okay, so 3. Okay, so it says 3 is 1. 4 is 2. I think I should add 1 to this. Yeah. Yeah, 4 is 3, good. 5 is 5. 6 is 8, good. 7. Okay. Now 100. Watch how fast this is. Oh, you know what? That's a really big number. Let's try 50. That's still too big of a number. Let's try 25. There we go. See? It's like instant, right? Let's try like 12. Okay? It's instant. 8. Good. Okay. Now if we do fib slow, okay, let's try 12. Yeah. This is going to take a while. So yeah. The reason why that one's slow... Wait a minute. 144? Let's see if we did if we labeled them. Yep, we did, okay. So the reason why it's so much faster is because fib slow is actually, the thing that it's doing bad is not that it's doing recursion, because you can do it fast using recursion, but the reason why it's slow is because we're not saving the values. We're not actually saving the values and returning it. So what we should be doing is, if that value is already called in the past, we could do it really quick recursively, but what we'd have to do is, the first time this gets called, we'd have to compute it. But if it ever gets called again, the value should be saved. So we don't have to recompute, we don't have to call its children. So if fib call gets called on, let's say, where p is going to be like 5 or something, we might have to calculate, okay, what are these other values if I call that. But if it ever gets called again, then we don't have to call, we don't have to figure it out again. We can just return 5. So that will be a lot faster, because then it doesn't have to go through this huge tree of computing, let's say, like, 1 or 2 or 3 or 4 millions and millions of times over and over and over and over again, just to get like a big number like 100. But instead, it just computes it once. In fact, it does each one just once. So then it's really fast, because then it just, in fact, it's linear, kind of computes it in linear speed. It just kind of starts at 0 and then goes all the way up till it gets to 12. That's it. So, yeah. So that's how you use lists. Yep. And see, this program all fits in one screen too. It's kind of funny how I made a non-recursive, same program that's a lot faster. And it's a lot shorter too. So that's a challenge for you guys, is maybe use a good use for recursion. One example is like chess. When I program chess, pretty sure I use recursion for that. Or maybe if somebody wants to do a recursive version, take the fib slow and actually alter it so that it saves the values. That's another thing you could do. Creepy. Okay, so what does this do? It just puts random numbers on the screen. I'll show you guys something really quick. So random numbers, that's another thing you can learn how to do. Randint will give you a random number between the first and the second number. And then the number rand will just give you kind of like a chance. So let's go ahead and just go back to the tutorial really quick. We'll just go to we'll just add a number 7. We'll say random. Okay. So the way random works is let's see here. Let's call it rand. Okay. But we don't need to do that. Let me just show you guys, because you can store this into values. But what I'm going to do is I'm going to hit math, then I'm going to go to probability. Okay. And I'm just going to press enter. But I'm going to keep pressing enter, 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 enter. And notice how it gives me a different value each time. These are values between 0 and 1. Okay. So if I go to rand, our program here, and I say something like if rand is greater than 1/3, you know, we can do like display 0 or something. Okay. So it should be doing it most of the time. Okay, so 1/3 of the time it should not display 0. Okay. But you could also do rand int, which is basically the same thing. You give it a lower bound and an upper bound. I'm not sure what this third number is for. I think that's how many increments or something. But if you just if it just display rand int, if I just display rand int and then I run rand 0, 1, 2, 3, 1, 3, 1, 0, 0. Okay. Yeah. Let's try putting a 2 there. Oh, I see. It gives me a list. Or a, is that a list? I'm not sure if that's a list. Yeah, I'm not sure. What kind of structure that was. But I guess that's another thing is you don't always know everything. And part of it is learn. I guess that's probably a good thing to end on is maybe I can't tell you everything. Maybe some things you'll have to learn on your own and have fun. So if you're not having fun and exploring, well, then I'm not sure if there's much point, because doing calculator programming with the TI-84 is, I've never heard of it as being a kind of a way to get income, I guess, or it's probably for the purpose of learning. But, you know, it could be for having fun. So I would pick one of those kind of reasons to code and do it because of that, and kind of enjoy what you're doing. Don't stress yourself out too much, and do it if you enjoy it. If that's what you like doing, then I'm sure you'll learn how to use these functions and make something creative, make something interesting. I want to see some here about some really cool programs that you guys make, and I'm really glad to help inspire that. So hope you guys enjoyed the tutorial. It's been about an hour and a half. Hope you guys learned something, and I will see you guys later. Bye.